Hi there, my name is Ms. Charalambidis, and in this video we will have a first introduction together on a system of linear equations. But before we do that, let's see some key concepts. First of all, when we refer to a linear expression, is any expression that can be written as a times x plus b times y equals c, where a, b, and c are numbers, any real numbers, and x and y are variables. So once again, although we simply see letters, we should be able to classify numbers from variables. A is the coefficient of x, b is the coefficient of y, c is a constant number, while x and y are variables. Now, when we have two such linear expressions, we say that we have a system of two linear equations with two unknowns. So, given two such linear expressions, let's call the first one as ax plus by equals c, and the second one as dx plus ey is f, or sometimes we simply call them as a prime x plus b prime y equals c prime, so that we want to show that a and a prime, b and b prime, c and c prime are related. But in order to allow you to understand that more easily, let's call them for now as d, e, and f. So we have two such linear expressions. Together, these two, they form a system of two linear equations of two variables. And once again, a, b, c, d, e, and f are numbers, while x and y are the variables. This, instead of defining this in this long way as system of two linear equations, two variables, we can use a shortcut and refer to it as a system of 2 by 2, or just 2 times 2. And yet, and again, it means two unknowns and two equations. Now, what do we want to do when given such a system? We need to find the solution of that. The solution of such a system is a pair of values x and y, which is always presented as a coordinate pair x, y, that do what? That satisfy both equations at the same time. At the same time, and all that at the same time can be simply stated by the word simultaneously. What does this mean in more simple words? This means that if x0 and y0 is a solution, then by substituting x0 and y0 properly in places of x and y, in both the equations, both will end up to valid statements. And by valid statements, I mean, for instance, 5 equals 5, 10 equals 10, and so on. In any case, something that holds true without any debate. So once again, solution to a system is that combination of values x and y that both, if replaced instead of x and y in both equations, they will produce true statements. Let's see some examples. Example number 1. Is the ordered pair 1 and 2 a solution to the system 2x plus y is 5 and 3x minus y is 10? Let's see. Based on what I just mentioned, if 1, 2 is a solution, that means that for x equals 1 and y equals 2 in both the equations, and here let me say that when given a system of equations, we begin always by naming them. I'm going to call top one by 1 and then the second one by 2. So 1, 2 would be the solution, and that would mean that for x equals 1 and y equals 2, if we substitute these values in both equations 1 and 2, I'll get something true. If not, then if I end up to something that I call a Nommy-G case, which is something weird, let's say 5 equals 10, then obviously we cannot follow the above definition, and that would simply mean that that given coordinate pair is not the solution to that system. So let's begin with the first equation. In 1, for x equals 1 and y equals 2, I get that 2 times 1 plus 2 is 5, which means that 2 plus 2 equals 5, 4 equals 5. That's obviously a Nommy-G case. That's something that it doesn't even make sense. And that means that the first equation of the two of this system does not even met, that is not satisfied. Do I have to check the second one as well? No, because we know that it would have been a solution if both were satisfied. Even if one is not satisfied, then it cannot be the solution. So here my answer would have been no, it's not. Let's do a second example. Example number 2. Is negative 3, 2 a solution to x plus 2y is 1 and x plus 5y is 6? Let's see. Again, in order for that to be a solution, that would simply mean that, let me name them 1 and 2. If I go in 1 and in 2 separately and place instead of x number negative 3 and instead of y number 2, I would produce true statements. Let's go in 1. In 1, for x equals negative 3 and y equals 2, we get that negative 3 plus 2 times 2 is 1, which means negative 3 plus 4 is 1, which means that 1 is 1. And that means that the first one is indeed satisfied. However, I'm not done. I need to check the second one as well. So Let me do that in the second one. Again, for x equals -3 and y equals 2, I get that x plus 5y, so -3 plus 5 times 2 is 6, which means -3 plus 10 is 6, which means that 7 is 6, and that is not obviously met. That's what I call omni-G case. So since both equations were not satisfied with these specific values of x and y respectively, this coordinate pair of -3 and 2 cannot be the solution to that system. Finally, let's see a case where indeed the proposed coordinate pair is the solution. Is 1, 1 a solution to x plus 3y equals 4 and minus x plus 5y equals 4 again? Once again, you should have got it by now. If x equals 1 and y equals 1, the first one will become 1 plus 3 times 1 equals 4, which obviously is true. And the second one, the minus x plus 5y, will also lead to a true statement. -1 plus 5 times 1, is it 4? Yes, -1 plus 5 is 4. So in this last third example, both equations are satisfied, which means that they lead to something true. So this makes this specific coordinate pair a solution to that system. Remember that all it takes in the end is just take these values, substitute them in both equations, and if both are simultaneously satisfied, then what we have is actually the solution to that system. That's all. I hope I cleared out things for you. If you still have issues and you don't quite understand any of these things, please let me know by leaving a comment below. As always, thank you for watching, and if you like that, you can always like and subscribe. Thank you for your time.